We are going to start now lecture 8 of chapter 9 class 11th mathematics, sequence and series. Now in this lecture we will study some properties related to the geometric progressions. So the first property we are going to discuss over here, it is, we are saying suppose we have a GP whose terms are A, AR square, AR cube and so on. This is a GP, this is given to us. Then what we have is that 1 by A, we are forming a new sequence 1 by AR square and so on. This is also a GP. We are saying K times A, that is if we are multiplying all the elements of this GP with a fixed constant K, we are multiplying all these terms with a fixed constant K. This is also a GP. We have, if we are talking about this, the product, if we take the product of K with this, we are getting it is K over A, K over AR, K over AR square and so on. This is also a GP. Then we are saying the powers, A raised to the power K, AR raised to the power K, AR raised to the power, AR square raised to the power K and so on. This is also a GP. So all these are geometric progressions. So the first term and the common ratio, they will be different from the initial GP, but all these are the GP. Now the first question we have is, if A, B, C are in GP, we have to prove that log A, log B and log C are in AP. So if A, B, C are in GP, it means we have B square is equal to AC. So this implies us, if we take log, it is log B square is equal to log of AC. This implies us that 2 log B, that is equal to log A plus log C, and this implies us that log A, log B and log C are in AP. These terms are in AP. Next we have is, if A, B, C, D are in GP, we have to prove that A plus B, B plus C, C plus D are also in geometric progression. So if A, B, C, D, these are in GP, what we have is, we have the value A. Next we have B is equal to A into some R, C is equal to A into R square and D is equal to A into R cube. Now if we substitute, we have to prove that these values, these three numbers, these are in GP. So if we calculate the value of the term B plus C square, we are talking about this middle term over here, it is B plus C square. The answer we have, it is AR plus AR square whole square. And if we are calculating the value of A plus B into C plus D, the answer we have, it is A plus B is A plus AR into C plus D is AR square plus AR cube. What we obtain from this is, from this first one, we are getting that A square R square into, we have taken AR common, 1 plus R whole square. From this second term we are getting, we are writing A common, we are left with is 1 plus R. From the second we are writing AR square common, we are left with is 1 plus R. Answer we are getting is A square R square into 1 plus R whole square. So clearly what we obtain is that B plus C whole square, that is equal to A plus B into C plus D, and this thing proves that B plus C is the geometric mean between A plus B and C plus D, that is these three terms, they are in GP. Next is, if A, B, C, D are in GP, we have to prove that these three terms are also in GP. So again we are writing, first term is A, second B we are writing AR, C we are writing AR square and D we are writing it is AR cube. Now we are calculating the value of B raised to the power n plus C raised to the power n square, and we are calculating the value of A raised to the power n plus B raised to the power n into C raised to the power n plus D raised to the power n. Now if we calculate the value of this first term, we have A raised to the power n r raised to the power n plus a raised to the power n r raised to the power 2n whole square. This is equal to, if we take a raised to the power n, r raised to the power n common, we get a raised to the power 2n, r raised to the power 2n into 1 plus r raised to the power n square. From the next two terms we have a raised to the power n means we are saying it is a raised to the power n plus a raised to the power n r raised to the power n into a raised to the power n r raised to the power 2n plus a raised to the power n r raised to the power 3n. Now if we write a raised to the power n common from both these, we obtain a raised to the power 2n into 1 plus r raised to the power n. R raised to the power 2n common, we are left with is 1 plus r raised to the power n, and what we obtain is that both these values, these are equal to each other. So what we obtain is that b raised to the power n plus c raised to the power n square is equal to a raised to the power n plus b raised to the power n into c raised to the power n plus d raised to the power n, and this thing proves that these three numbers, they are in GP. Next is, if a square plus b square, ab plus bc and b square plus c square are in GP, we have to prove that a, b, c are in GP. So it is being given that a, b plus b, c square is equal to a square plus b square into b square plus c square. Now if we open whole squares, we obtain a square b square plus b square c square plus 2ab square c, that is equal to a square b square plus a square c square plus b raised to the power 4 plus b square c square. Now this b square c square gets cancelled. This a square b square gets cancelled. What we obtain is b raised to the power 4 plus a square c square minus 2ab square c is equal to 0. And this is the formula for this term. It is the, in place of this we can write it is b square whole square. In place of this we can write it is ac whole square. So this is the formula for b square minus ac whole square is equal to 0. And this implies us that b square minus ac is 0. So we get b square is equal to ac, and b square is equal to ac implies us that a, b, c, these three numbers, these are in GP. Next we have is, if mth, nth and pth term of a GP form three consecutive terms of a GP. So we have a GP whose mth, nth and pth term we are talking about. So we are saying the mth term is Tm is equal to a r raised to the power m minus 1. Tn is equal to a r raised to the power n minus 1, and Tp is equal to a r raised to the power p minus 1. And it is being given that these three terms, these are the three consecutive terms of another GP. So what we obtain is that a r raised to the power n minus 1 square is equal to a square r raised to the power m minus 1 r raised to the power p minus 1. So a is not equal to 0, so this a gets cancelled, and what we obtain is that r raised to the power 2n minus 2 is equal to r raised to the power m plus p minus 2. So this implies us the value of r is not equal to 0. So this implies us that 2n minus 2 is equal to m plus p minus 2. So this 2 gets cancelled. So we obtain that 2n is equal to m plus p. So this gives us that n is the arithmetic mean between m and p, and this thing proves that m, n and p are the three consecutive terms of an AP. Now next is, if 4th, 10th and 16th term of a GP are x, y and z. So we have x is equal to a r raised to the power 3, y is equal to a r raised to the power 9, and the 16th term we are talking about z, that is equal to a r raised to the power 15. we have to prove that x, y, z are in GP. So to prove that x, y, z are in GP, we are talking about the value of y square, that is equal to a square r raised to the power 18. And if we calculate the value of x, z, the answer we obtain it is a square r raised to the power 3 r raised to the power 15. We are getting it is a square r raised to the power 18. Now combining both these results, we obtain y square is equal to x into z. We obtain y square is equal to x into z. So this thing proves that x, y and z are in GP. Next is three numbers are in AP and their sum is 15. So three numbers are in AP, so we are considering that those three numbers, they are a minus d, a and a plus d, and their sum we obtain it is 3a is equal to 15. So a is equal to 5. So next thing that is given to us is, if 1, 3 and 9 are added to them, they form a GP. So we are saying we have 5 minus d plus 1, then 5 plus 3, then 5 plus d plus 9. So these three numbers, they form a GP. We have to find these numbers. So what we have is 8 square is equal to 6 minus d into 14 plus d. So if we solve this equation, we obtain 64 is equal to 84 minus 8d plus d square. So this implies us d square plus 8d minus 20 is equal to 0. This implies us d plus 10 into d minus 2 is equal to 0. This implies us that the value of d is minus 10 or 2. So we have the value of a is equal to 5, d is equal to minus 10, a is equal to 5, d is equal to 2. So if we substitute the values in this formula, we will obtain, we have 5, then we have it is 15, and then we have it is minus 5. And if we use this result, we are saying the first term we have 5 and the value of d we have it is 2. So it is 3 and this is 7. So these are the required numbers. Either it is this number or it is this set of numbers. Next we have is, the next topic we have is geometric mean. So we are saying let a and b be two given numbers, and we say that g is the geometric mean between a and b if a, g and b are in GP. So we are saying a, g and b, these are the three numbers which are in GP, then this g is said to be geometric mean between a and b. So this thing means, what this thing implies, it is a GP means that g over a is equal to b over g. So this implies us that g square is equal to ab. So this implies us that g is equal to square root of ab. So if we have to calculate the geometric mean between two numbers, it is square root of ab. Now we have some properties over here or some results over here. First is the geometric mean between two positive numbers is positive number. The geometric mean between two negative numbers is a negative number. We are saying if we have a is equal to minus 1 and b is equal to minus 4, then the geometric mean we write g, that is equal to minus square root of minus 1 into minus 4. If we are saying a is equal to 1 and b is equal to 4, then the geometric mean will be square root of 1 into 4. So this sign we are saying this is according to the signs of a and b. And last we have is that the geometric mean between two numbers of opposite sign, it does not exist. So here are some problems based upon this. First is find the geometric mean between 6 and 24. So the geometric mean between 6 and 24, it is square root of 6 into 24, and sign over here will be positive. It is square root of 144, that is equal to 12. Next is minus 9 and minus 25, both these numbers, these are negative. So we have it is minus of square root of minus 9 into minus 25. We are getting this is equal to minus square root of 225, that is equal to minus 15. And in the last case we are saying what is the geometric mean between minus 6 and 9. So we are saying these are of opposite sign. These are of opposite signs. So what we obtain is that the geometric mean does not exist. Next is find two positive numbers a and b whose arithmetic mean and geometric mean are 34 and 16. So it is being given that the arithmetic mean means a plus b by 2 is 34 and geometric mean means square root of a b is equal to 16. Now we know that a minus b whole square, that is equal to a plus b whole square minus 4ab. Now from this equation we have the value of ab is equal to 256. From this first equation we have the value of a plus b is equal to 68. Now if we substitute these values in this equation, we obtain a minus b square is equal to 68 square minus 4 into 256. So the value of a minus b we obtain, that is equal to plus minus 60. When you solve this value, you will obtain a minus b is 60. Now we have two equations. One equation we have it is a plus b is 68 and second is a minus b is 60. We are talking about two situations over here. It is a plus b is 68, a minus b is 60, a plus b is 68, a minus b is minus 60. Now if we solve both these equations, both these pairs of equations, we obtain a is equal to 64, b is equal to 4, or a is equal to 4 and b is equal to 64. So we are saying the required numbers are a is equal to 64 and b is equal to 4, or a is equal to 4 and b is equal to 64. So these are the two positive numbers that if we can have. Next is find the value of n so that this term may be the geometric mean between a and b. It means it is given to us that a raised to the power n plus 1 plus b raised to the power n plus 1 divided by a raised to the power n plus b raised to the power n, that is equal to square root of a b. Now if we cross multiply these terms, we obtain a raised to the power n plus 1 plus b raised to the power n plus 1, that is equal to, this term we can write it is a raised to the power 1 by 2 b raised to the power 1 by 2. So what we obtain from this is a raised to the power n plus 1 by 2 b raised to the power 1 by 2 plus a raised to the power 1 by 2 b raised to the power n plus 1 by 2. So this implies us that a raised to the power n plus 1 minus a raised to the power n plus 1 by 2 b raised to the power 1 by 2, that is equal to a raised to the power 1 by 2 b raised to the power n plus 1 by 2 minus b raised to the power n plus 1. Now if we take a raised to the power n plus 1 by 2 common, we are left with this a raised to the power 1 by 2 minus b raised to the power 1 by 2, that is equal to b raised to the power n plus 1 by 2 into a raised to the power 1 by 2 minus b raised to the power 1 by 2. Now a and b, these are given, it is being given that a and b, these are not equal. So what we obtain is that both these values, these are equal and they are non-zero. So these two values gets cancelled and we are left with is that a by b raised to the power n plus 1 by 2 is equal to 1. So this implies us that n plus 1 by 2 is equal to 0. So this implies us that n is equal to minus 1 by 2. So this is the required value of n. What we have to calculate in this question is we have to find the value of n for which this thing holds. So we are saying for n is equal to minus 1 by 2, this number is the geometric mean between a and b. Next we have is, if capital A and capital G are the arithmetic and geometric mean between two distinct positive numbers a and b, we have to prove that a is greater than g. So it is being given that a is equal to a plus b by 2 and g is equal to square root of a b. Now if we calculate the value of a minus g, the answer we have is a plus b by 2 minus square root of ab. So this is equal to a plus b minus 2 root ab by 2, and this is equal to a, this value if we look at, if we take 1 by 2 common, we obtain square root of a minus square root of b whole square, and clearly this term, it is always greater than 0 because it is being given that a and b, these are the two distinct numbers. So what we obtain from this is that a minus g is greater than 0, that is a is greater than g, that is arithmetic mean is always greater than the geometric mean. So this is very important result that you should remember. Next we have is, if a and g are respectively the arithmetic and geometric mean between two positive numbers a and b, we have to prove that the quadratic equation having a and b as its roots is given by this formula. So we have the value of a is equal to a plus b by 2. The value of g we have, it is square root of ab. Now we are saying we have to prove that the quadratic equation with a and b as its roots. So if a and b are the roots of the quadratic equation, then the quadratic equation will be x square minus sum of the roots x plus product of the roots is equal to 0. Now from this first result, we have the value of a plus b is equal to 2 times a. So we obtain x square minus 2ax, and the square root of a b is equal to g. So we are having a b is equal to g square. So we are writing plus g square is equal to 0. So this is the equation we are talking over here. This is the equation we are saying that the quadratic equation having a and b as its roots is given by this equation. Next is, if a and g are arithmetic and geometric mean between two positive numbers, we have to prove that the two numbers, they are in this form, that is a plus minus square root of a square minus g square. So we have already seen that if a and g, these are the roots, then the quadratic equation we have, it is formed by this a plus b into x plus ab is equal to 0, and we have seen that by substituting the value of a and g in this equation from the previous slide, we have obtained x square minus 2ax plus g square is equal to 0. Now if we solve this quadratic equation for the values of x, we have to find the two positive numbers, that is we are talking about the numbers a and b. So the values of x we obtain, it is minus a plus minus square root of 4a square minus 4g square divided by 2. So we are saying the values of a and b, that is x is equal to a plus minus square root of a square minus g square. So these are the two numbers that we have. So these are the a plus minus square root of a square minus g square, these are the required numbers. Next we have is, if x, y, z are distinct positive numbers, we have to prove that x plus y into y plus z into z plus x is greater than 8xy z. Now we know that the arithmetic mean is always greater than the geometric mean. So if we apply this result for all these three numbers pairwise, the first result we have is that x plus y by 2 is greater than square root of xy. Second is y plus z by 2 is greater than square root of yz. And third we have is z plus x by 2 is greater than square root of zx. Now from these three results we can write x plus y is greater than 2 times square root of xy, y plus z is greater than 2 times square root of yz, and z plus x is greater than 2 times square root of zx. Now if we take the product of these three terms, we have x plus y into y plus z into z plus x. This is greater than 8 times, it is square root of x, we get x, square root of y, we get y, and square root of z, we get z. So we are obtaining this result that x plus y into y plus z into z plus x, this is greater than 8 times x, y, z. And this is what we have to prove. Next we have is, if a, b, c, d are 4 distinct positive numbers and they are in GP, we have to prove that a plus d is greater than b plus c. So if these 4 numbers these are in GP, clearly we have a, b, c is in GP. And if these 3 numbers these are in GP, what we obtain is that a plus c by 2 is greater than the geometric mean between these two numbers a and c, and the geometric mean between these two is b, because it is given that these 3 numbers they are in GP. So it is being given that this is greater than b. So this implies us that a plus c is greater than 2 times b. Again we have b, c, d are in GP. So what we obtain is that b plus d by 2 is greater than c. So we obtain b plus d is greater than 2 times c. We have these two results now. Now if we add both these equations, we obtain a plus b plus c plus d is greater than 2b plus 2c. So this implies us that a plus d is greater than b plus c. This thing implies us that a plus d is greater than b plus c. Next is, the sum of two numbers is 6 times their geometric mean. So suppose we are saying the two numbers that we have, these numbers are a and b. So it is given that a plus b is equal to 6 times their geometric mean. So we get a plus b divided by 2 times square root of ab is equal to 3. Why we are writing it in this form? Because we want to find the numbers, ratio of the numbers. So if we apply the component of dividend over here, we obtain a plus b plus 2 root ab divided by a plus b minus 2 root ab is equal to 3 plus 1 divided by 3 minus 1. The answer we obtain, it is equal to 2 by 1. Now this is the formula for whole square. It is square root of a plus square root of b divided by square root of a minus square root of b whole square. That is equal to 2 by 1. So what we obtain from this is that square root of a plus square root of b divided by square root of a minus square root of b is equal to square root of 2 by 1. Now again applying componendo dividendo, we obtain square root of a plus square root of b plus square root of a minus square root of b divided by square root of a plus square root of b minus square root of a plus square root of b, that is equal to square root of 2 minus plus 1 over square root of 2 minus 1. And this implies us, this b gets cancelled, this a gets cancelled, we obtain square root of a by square root of b is equal to square root of 2 plus 1 divided by square root of 2 minus 1. So this implies us a by b is equal to square of this term, it is 2 plus 1 plus 2 root 2 divided by 2 plus 1 minus 2 root 2. So the answer we obtain from this, it is equal to 3 plus 2 root 2 divided by 3 minus 2 root 2. So this is the required value. We are saying the ratio of A is to B. It is given by this result. It is 3 plus 2 root 2 is to 3 minus 2 root 2. So this is the ratio of the values A and B. Now next is, if the arithmetic mean and geometric mean of roots of a quadratic equation are 8 and 5, then we have to obtain that equation. So suppose we are saying the roots of this equation, they are a and b, and am and gm of these roots are 8 and 5. So it is being given that a plus b by 2 is equal to 8 and a into b square root is equal to 5. So this implies us a plus b is equal to 16 and this implies us a b is equal to 25. So we have obtained the sum of roots, we have obtained the product of roots. Now to obtain the equation, we are writing it is x square plus sum of roots, it is minus 16x, and product of roots, it is 25, is equal to 0. So the required equation is x square minus 16x plus 25 is equal to 0. This is the required equation. Next is, if the arithmetic mean and geometric mean of two positive numbers a and b, it means a plus b, that is equal to 2 times a, the arithmetic mean, and a into b is given to be g square. This is from the geometric mean, and the ratio of these two, it is given to be, the ratio of am to gm, it is given to be m is to n, that is the ratio of a to g is given to be m is to n. We have to show that the ratio of a and b is this. Now from our previous question, we already know that the value of a and b, it is given by a is equal to a plus square root of a square minus g square, and value of b is given by a minus square root of a square minus g square. Now we are being given that a is to g is m is to n. So this thing implies us, we are talking about this result, this implies us that a is equal to k times m for some k and g is equal to k times n for some k. Now we want to calculate the value of a is to b. We have a plus square root of a square minus g square divided by a minus square root of a square minus g square. Now if we substitute these values of a and g in this equation, we obtain this is equal to km plus square root of k square m square minus k square n square divided by km minus square root of k square m square minus k square n square. Now this k gets cancelled from whole of this equation, and the answer we obtain is that a is to b is equal to m plus square root of m square minus n square divided by m minus square root of m square minus n square. We obtain this result. This is the ratio of a is to b. This is the ratio of a is to b. And this is what we have to prove. Next question we have is, find two positive numbers whose difference is 12 and whose arithmetic mean exceeds the geometric mean by 2. So suppose we are saying the two numbers, they are a and b, and it is being given that their difference is 12. We have assumed that A is greater than B. Second thing that is given is that their arithmetic mean is greater than geometric mean by 2. So it is being given that A plus B by 2 minus square root of AB, that is equal to 2. So we get A plus B minus 2 root AB is equal to 4. So we get square root of A minus square root of B whole square is equal to 4. So we get square root of A minus square root of B is equal to 2, because we have already assumed that A is greater than B. Now from this equation we can write square root of A minus square root of B into square root of A plus square root of B is equal to 12. Now if we substitute this value over here, we obtain square root of A plus square root of B, that is equal to 6. Now we have two equations. One equation we have, it is square root of A minus square root of B is 2. Second is square root of A plus square root of B is 6. Now if we add both these equations, we obtain 2 square root of A, that is equal to 8. This implies a square root of A is equal to 4, and this implies as A is equal to 16. If we subtract both these equations, we obtain 2 times square root of B is equal to 4. This implies a square root of B is equal to 2, and this implies as B is equal to 4. So we are saying the values of A and B that we have, A is equal to 16 and the value of B that we have, that is equal to 4. Next we have is, if x is a real number, we have to find the minimum value of 3 raised to the power x plus 3 raised to the power 1 minus x. Now we know that the arithmetic mean is greater than geometric mean. So if we are considering the two terms, first term we are considering 3 raised to the power x, and second we are considering 3 raised to the power 1 minus x, and we are using the result that AM is greater than GM. So what we obtain is that 3 raised to the power x plus 3 raised to the power 1 minus x by 2 is greater than 3 raised to the power x into 3 raised to the power 1 minus x under root. Now we require the value of the term 3 raised to the power x plus 3 raised to the power 1 minus x, and the answer we obtain, we are saying this implies us that 3 raised to the power x plus 3 raised to the power 1 by x, it is greater than 2 times. If you look at this value, this will become 3 raised to the power x plus 1 minus x. So it is square root of 3. So what we obtain from this result, that this value is greater than this value. So minimum value of this term, it is equal to 2 root 3. So the minimum value of this term is 2 root